One of the greatest achievements of the present century has been the quantity production of essential and luxury goods and the subsequent rise in the general standard of living. Scenes like these are accepted features of life in many parts of the world today, and they have been made possible by the constant developments of the mechanical handling industry, whose engineers have matched the increasing demand of production by new techniques. Foremost in this field is the company of G.W.King Limited, whose advanced methods of integrated handling are an established feature of any progressive society. For over 40 years, Kings have designed and built handling equipment of every kind. And in this film, we're going to show examples of equipment designed to handle 3 widely differing products. In a modern motor car factory, thousands of separate components are on the move every minute of the day. And here at the vast Vauxhall car plant at Luton, where so much King equipment can be found, we're going to show how parts for plating are handled. This King stand-run conveyor carries up to 50 different types of components from store to plating plant and then to final inspection. One of the few manual operations is the loading, which is carried out on these dead lines or empty carrier storage loops. Between these storage loops and the plating plant vats, there are 3 live line storage points or spacer sections. Their purpose is to ensure that a supply of loaded carriers is always available at the start of the plating sequence. The loaded carriers are held here at the first of the spacer sections until the next section is vacant, when they move up and their place is taken by carriers following behind. The carriers are fed to the plating plant transporter, 4 at a time in 2 pairs, and the filled spacer sections release this number each time the plating plant is ready to receive a fresh load. In order to connect with the plating plant transporter, it is necessary for the carriers to travel down a vertical bend. As the carrier trolley must be positively located to the conveyor chain on an incline, and a rester unit is incorporated at this point. This holds the carrier trolley until a driving dog on the chain engages with a slot in the trolley shoe. After negotiating the incline, the carriers are held in the last of the spacer sections to await transfer to the plating plant transporter. This transfer from one system to another must be perfectly synchronized, so that the carriers are stationary on the conveyor in readiness for the transfer arms to move into position to take the load. The speed at which this transfer operation is carried out may appear slow, but it is, of course, governed by the transporter as it travels through the various plating processes at under 2 feet per minute. It is necessary for the transporter to travel at 2 different levels to move the components over and into the various vats of solution. The jigs are first raised to high level to allow them to travel over the vats. Then lowered to carry them through the solutions. Here the components receive 2 deposits of copper. In the next plant, which we will see later, they receive a coating of nickel and finally one of chromium. At the offload end of the plant, another transfer device takes the jigs, turns them round and returns them to the King conveyor. Although somewhat different from the load transfer at the start, this offload transfer is carried out with the same smoothness and precision. The empty carriers are held in this live storage section until the load has been transferred. As the transfer arm turns for its next load, it energizes a solenoid and so allows the loaded carriers to move on. The components then go through a polishing process before being loaded onto this conveyor. The carriers are loaded up in these deadline storage loops and transferred to the main circulating conveyor that serves the chromium plating plant. There are similar spacer sections in this conveyor to those of the copper plating plant to ensure that there is always a supply of components to feed the transporter. As this plant is capable of plating 1,600 square feet an hour, it is vital to keep a supply of components at the onload station. At peak output, the entire plant, that is to say, both the copper and the chromium plant processes, require only 18 men between them to keep the two systems operating. The offload transfer device is exactly the same as on the copper plating system. In fact, both plants are mechanically identical throughout. The conveyor and other mechanical features are able to receive maintenance during solution changes in the baths. Again, the transfer unit is perfectly synchronized to allow the arms to be well clear before actuating the solenoid which releases the loaded carriers. The finished components are finally offloaded onto a belt conveyor for inspection, and the empty jigs travel back to the first of the deadline storage loops to start their journey over again. The last few years have seen considerable advancement in the design and use of diesel engines, and their value has been proved in many fields, particularly in lifeboats and small seagoing craft. Their low running costs make them suitable for commercial and public transport vehicles, where economy is one of the major factors. F. Perkins Engines Limited have pioneered the development of the diesel engine in this country, and today at their Peterborough factory they produce approximately 1,000 every day. The engine assembly building and test shop are equipped with G.W.King's handling systems. A remotely controlled King Marvex electric chain hoist is used on a runway to hoist the blocks over a gangway and down to the start of the engine assembly slat conveyor. The adjustable grab is designed to deal with the full range of Perkins engines. The normal lift speed for this particular installation is 30 feet per minute, with a creep speed to allow fineness of control. The hoist traverse is automatic to the end of the runway at a speed of 100 feet per minute. The first operator on the bench conveyor is able to call down the block when it is required. Before lowering it onto the jig, the engine is turned on its side to facilitate the operations which follow. As the hoist is lifted to its stop, the power traverse automatically takes it back to the other end of the runway, ready to receive the next cylinder block. Perkins engines are used all over the world and are fitted as standard equipment on all types of agricultural machinery, vans, trucks and boats. At this point, another King electric hoist is used to return the engine to a vertical position. At the end of the assembly conveyor, the engines are virtually completed and are then transferred to a dual-duty twin-rail overhead conveyor by this drop section, which, when raised, forms part of a deadline loop. Cutout switches prevent the drop section being operated if the load trolley is out of position. These drop sections can be entirely automatic on a live line, but here a deadline is more convenient. When the section has been latched to the conveyor track, the carrier can be pushed out into the main circulating conveyor. The engines next travel up a vertical bend, round a wheel corner, and through the wall to the test shop. Here are a number of dead lines, each capable of holding a loaded carrier. As the engines travel along the main conveyor, they are automatically switched into the first empty deadline. A transporter running the whole length of the shop is used to transfer an engine from the dead lines to any test bed that becomes available in any part of the shop. All conveyor track ends have automatic stops to prevent load trolleys running off. Each engine is run on test for a set number of hours according to type. After an initial running in and warming up period, the engine is subjected to varying loads applied by an electric generator to which the engine is coupled. At the completion of the test, the engine is hoisted back onto the transporter. Then fed into the main conveyor, where it travels into the department where slave equipment fitted for the test run will be detached. The conveyor carries the engine from the test shop through another wall and up a vertical bend. Due to the length of the conveyor and the very heavy load carried on it, there are 3 drive units situated at strategic points throughout the system. These Caterpillar drives are designed to work on any straight length of track, as distinct from sprocket drives, which need a horizontal bend. On long vertical bends, special trolley stops are fitted as a safety device to prevent trolleys running away. At this point, the pusher dogs are lifted clear of the load trolley to allow it to be moved independently of the main conveyor. The operator is now able to remove the slave equipment. It is then a simple matter to move the engine a short distance along the track until it re-engages with the lowered conveyor chain. The engines are next held on these buffer storage lines, each holding a certain type of engine. Any particular type can be drawn off and fed into the main conveyor as required. From storage, the engines travel on the main dual-duty overhead conveyor until they arrive at the department for fitting the auxiliary components. Here they are lowered by another drop section onto a floor truck, which will be connected to an under-tug floor conveyor circulating this department. As the chain of this conveyor runs below ground, the floor space is completely free of obstruction. The truck is pushed forward to the start of the conveyor and the driving peg engaged with the chain. Should the truck meet any obstruction, the front bumper automatically disengages it from the chain. The under-tug floor conveyor travels at a speed convenient for the men to work. It is in this shop that all the auxiliary components, such as dynamos, starter motors, and fuel pumps, are fitted. When the engine has circulated the under-tug conveyor system, it is complete in every mechanical detail. Here it is hoisted onto a King super track overhead runway leading into the paint shop. The engines are all painted special colors for easy identification. Finally, the engines are lowered from the runway to a roller conveyor by a pneumatic ramp. In the dispatch bay, the last item of King's equipment is this double-beam overslung crane with a capacity of 1.5 tons and a span of 58 feet. Perkins, the pioneers of the diesel engine, always use equipment by Kings, the pioneers of mechanical handling. Now, for an entirely different application of advanced mechanical handling, we turn to Europe's most up-to-date egg packing station, recently completed for Messrs. J. Sainsbury Limited at Kenninghall, Norfolk, where by the use of King overhead conveyors, over 3 million eggs are handled every week. This plan of the building shows the compact layout of the conveyors, which are the sole means of transport throughout the system. The eggs are taken direct from the lorries and fed into the graders at these points. The graded eggs are then loaded on the carriers, waiting in these deadlines or sidings. Next, they are fed into the circulating conveyor, which takes them across the building to the packing area. They automatically enter the packing line allocated to that particular grade, and the operator on this line simply cartons the eggs and sends them to the dispatch bay. Now let us take a look inside the packing station itself. The eggs arrive in crates containing 1 gross. The trays of eggs are then placed on small trolleys, which take them through to the candling booths for a light test for imperfections, and onto the grading machines, where they are automatically sorted into 5 grades from small to extra large. At this point, a King's stand-run conveyor takes over the load until it is cartoned and ready for dispatch. The graded eggs are placed on one of the stainless steel carriers in the deadline. The destination keys are set according to the grade of egg, and the carrier is then fed into the main circulating conveyor. Each deadline loop serving the graders accommodates 2 empty carriers. When a full one has been fed into the main conveyor, the next empty one is automatically switched into the loop. Should the deadlines be full, the empty carrier circulates until there is a loop able to accommodate it. Before vertical bends, there are spacer sections to allow the trolley shoe to engage with a dog on the driving chain to positively locate it to the conveyor. As soon as the carriers reach the top of the incline, the dog disengages with the trolley shoe, and the carrier is no longer positively held to the conveyor chain. The full carriers now circulate on the conveyor until they reach the far end of the building. As a matter of interest, the conveyor system in this factory is approximately 700 feet in length, and the speed is 33 feet per minute. Although this equipment runs continuously, the high standard of cleanliness demanded by the food industry is constantly maintained. The destination keys, which were set as the carrier left the grading loop, determine which of these 9 packing lines the carrier will enter. 7 carriers can be accommodated on each line, but if any particular line is full, it will continue to circulate the system until there is a vacant place. Since all the eggs on any one line are the same grade, it is simple for the operator to take them from the conveyor and pack them into cartons. As each carrier is unloaded, the destination keys are set to neutral and returned to the main conveyor. the indexer system moves up the next loaded carrier, and all the following carriers move up, leaving the last position empty to receive another load. Handling over 3 million eggs a week is a major achievement, and so successfully is this carried out by King conveyors that eggs are collected from farms and passed through the system ready for delivery to shops within 24 hours. These are only 3 of the many King handling systems of advanced design in operation throughout the world. Where once mechanical handling was just a means to assist manual labor, it is now the major industrial feature around which production is planned and built. At the Stevenage factory of G.W.King Limited, design and development never cease. New techniques are constantly being evolved to meet the challenging problems of engineers throughout the world.